Hi everyone, welcome back to our Mathematics T online lesson. I hope all of you are well and energetic. We are still in chapter 12, but it will be our last skill for Sem 2, which is a method of iteration. Now, based on this chart, you can see that we have covered numerical integration over here, where we use the trapezium rule to estimate the area under a curve. We have also covered numerical solution of equation. Here we learn graphical method and intermediate value theorem. We use this graphical method and intermediate value theorem to find the number of real roots and to locate a root of an equation approximately. Now we have also learned Newton-Raphson method. Newton-Raphson method can be used to obtain a more accurate estimate of a root, which cannot be done using graphical method. So for today's lesson, we will learn how to use method of iteration, which is also a method used to obtain a better approximation of a root of an equation. Now, just like a Newton-Raphson method, method of iteration is also a repetitive process. Using the iterative formula, you repeat the process by substituting the successive approximation into the formula until the required degree of accuracy is achieved. Then you will get a very good approximation, or very close approximation to the root of the equation. Let us compare and see the difference between the Newton-Raphson method and the iterative method. Now, for Newton-Raphson method, before you start using the formula, first you must rearrange the equation that you need to solve into fx equals 0. But for method of iteration, you need to arrange the equation into another form where x is the subject. As you see here, it must be x equal fx, the rest at the right side. I'll give you an example. Now, if you are asked to find a solution for this equation, now if you are using Newton-Raphson method, then first you must rearrange it into this form: x squared minus 6x plus 2 equals 0. Then you have to let fx be this one, this part. Then only you use the Newton-Raphson method formula to find the approximation for the root. But for method of iteration, you rearrange it into x equal fx. Example, I can rearrange it into this form. If you look here, I can divide 6 on both sides. You will get x equal x squared plus 2 over 6, which is this. Or I can also rearrange it into this form. X equals 6 minus 2 over x. How do I get this? I minus 2 on both sides. Minus 2 on both sides. I get 6x minus 2 over here. Then I divide x. You will get this. Or I can also rearrange it into this form. X equals square root 6x minus 2. How do I get this? By minus 2 on both sides. Then I square root both sides. I will get this. Or I can also rearrange it into this form. How do I get this? I move x squared over here. And then I factorize this. Factorize x. Then I divide 6 minus x on both sides. I will get this. So as you can see here, there are 4 different rearranged forms that you can use to find the approximation for the root. But there is only not every one of these is suitable to be used. Sometimes the rearranged form is not suitable to use to find certain root. So in the next lesson, I will explain to you how do we know which one is suitable and which one is not suitable. Now as for today, I will explain to you how iterative method works and how do we use it to find the root. The next lesson, I will explain to you how do we determine which rearranged form do we use. Means which one is suitable, which one is not suitable. Now let me show you the visual representation so that you can understand how this iterative method works. Now as you know, for iterative method, you start by writing the equation in this form. Now, based on this equation, if you use graphical method to find the root, you will need to draw a graph for y equal x. And then you need to draw another graph which is y equal fx. Now let's draw y equal x here. Then let's say y equal fx equal this. Now you can see from the graph, there are two roots here. One here, one here. See? Now let this root be alpha. Alright? Now let x naught be the initial approximation. If I substitute this initial approximation into fx, you will get fx naught here, and you will get this value fx naught. Now this value is actually equal x1. How do I know? Because if I draw this line parallel over here, parallel to x-axis, and on this line it is y equal x. This line y equal x means this value will equal this value, which is x1. So we can conclude that x1 is actually equal this value. Now what happens if we repeat the process? Now I'm going to use x1. Now you can see that x1 is a closer approximation to x0. It is closer to the root now. Now what if I repeat the process by using x1? Now I'm going to substitute x1 into fx. Here. This value will be equal fx1. And if I draw the line over here into y equal x, it will match with x2. Now since on this line y equal x, that means x2 will equal fx1. And you can see that x2 is now even closer to the root. Now I substitute x2 into fx again, and I will get fx2 over here. And fx2 will match x3 over here. You see the point on y equal x here. Go down x3, and you can see x3 is getting even closer to the root now. That means if I repeat the process, I continue and subsequently I will get a very good approximation of the root by using this formula. Is the formula for method of iteration. Now let us move to our first example. Now if you have your textbook with you, go to checkpoint 12.2, question 1. Now the first part of the question, they ask you to sketch the graphs of this one, y equal x power 3, and this graph on the same axis to show that the equation has exactly one real root. Now you can see that this is actually the graphical method, right? This part x power 3, and here 100 minus x is the other graph. So I hope you can still remember what you learned in graphical method. First you sketch y equal x power 3. You sketch the axis. You will get y equal x power 3 as shown in the diagram. Then we will draw y equal 100 minus x. It's a linear graph, straight line. You get 2 points and you use a ruler. You get this. Now as you can see in the graph, there's only 1 point of intersection, which means there is only one real root. So you make a statement. Since there is only one intersection point between the two graphs, therefore it is shown that equation x power 3 plus x equal 100 has exactly one real root. Now for the second part of the question, they ask you to use the iteration method. Now the rearranged form here has been given to you, right? The initial approximation is also given to you. So you just need to repeat the process, right, by substituting x naught into this equation, this formula, right? Now let me show the working. Now first, s naught is 4. So the first approximation, you substitute 4 into the formula and use your calculator. You get this. You must write out the working. Now since the question asks you to round off to 3 decimal places for the final, then your approximation must be at least 2 decimal places more than the one stated in the question. So since the question wants you to round off to 3 decimal places, I will round off to 5 decimal places here for the first approximation. So I repeat the process. I'm going to take x1 and I substitute into the formula again. I must write out the working and then use my calculator to get the answer. Now the first 2 approximation, you must remember, you must show the working. You must show the working for the first 2 approximation. Subsequent approximation, you just need to write the answer. You don't need to show the working. So the x3, I will use x2, substitute into the equation, and then I will get 4.56978. And then I will repeat the process by using x3, substitute into the formula, and I get x4. You must continue the process until you get two answers which are exactly the same. Right? So as you can see here, these two answers are exactly the same. So you stop and you make the conclusion that the root is 4.570, which is round off to 3 decimal places. Now with this, you should be able to do checkpoint 12.2, question 1 until question 7. Right? So I need you to try question 1 to question 7 first. Before I give another lesson on how to know which rearranged form of equation is suitable to use. If rearranged form of the equation is suitable, it will converge to the root. But if it is not suitable, it will diverge. As you can see here, this graph, this visual representation, you can see that this rearrange this process lead the approximation to this root, but the approximation does not come to this root, which means this rearranged form is not suitable to find this root. So that's all for today. Keep yourself motivated. Keep yourself occupied with beneficial activities. Keep yourself busy. Right? Okay, goodbye.
Bapa kami yang ada di surga, dimuliakanlah namamu. Datanglah